Okay, so the first thing we want to go over here is the arc length of a circle, or a sector of a circle. And a sector of a circle, that's just fancy words for a portion of the total way around a circle. So if we are thinking about some portion of the way around a circle, we're going to ultimately talk about two things. We're going to talk about the area inside that pie-shaped piece of the circle, and we want to be able to talk about the portion of the circumference of the total circle, represented as the edge of this piece of pie, which we call the arc length. So let's go back and discuss for just a moment the fact that we know how to find here the length of the entire circumference of the circle. That's 2 pi times the radius, and this came about when we discussed what a radian was in general, and that if we have a radian, which is a measure of the size of the circle, the radius, we can do 2 pi of those all the way around, and that gives us the circumference of the circle. But like I said, we're interested in just this small portion of it here, and so we need to discuss what portion of the total we have. And so how much of the total circle we have we have theta out of 2 pi. That is assuming that theta is in radians. So if theta is in radians, then we have theta out of 2 pi is the portion that we have, and we can think about that portion of the total circumference. And so if we're interested in the area of the sector, right, which is, like I said, that little piece here, then we want that portion of the total circumference. And so we want theta out of 2 pi times the circumference. Well, we know that the circumference from earlier is 2 pi times the radius, so this is theta out of 2 pi times the 2 pi radius circumference. The 2 pi's cancel, and we get theta times the radius. So again, this means that theta, the angle, must be in radians in order to use this formula to find the arc length of a portion of the circle.